Factor completely. When an expression involves negative exponents, you could rewrite that so that you recall that a negative exponent really means a reciprocal. And if you wanted to try and factor this, we could factor out this denominator. If we multiplied everything through by an x squared, we could reduce and have no denominator. So I can multiply out this 1 over x squared. But that means I'll have an 8x squared, so that 1 over x squared times x squared would just leave me with the 8, plus 10x minus 25. Now this looks a little more typical of what we would like to try and factor. Again, since we have 3 terms and there's nothing common to all 3 terms, we'll break down the first, 1 times 8, 2 times 4, x times x, and break down the last, 1 times 25, 5 times 5. So this 1 over x squared will sit out in the front, and now we'll have 2 sets of parentheses. In the front of both parentheses, I'll use the factors from the first term, starting at the end of the list, 2x and 4x. And from the last term, we'll use the 5 and 5. And again, since the last sign is subtraction, I'm going to try and figure out what the middle term needs to be. The signs will be different. 5 times 4x is 20x. 2x times 5 is 10x. I'm going to have to 1 is a positive and 1 is a negative. But when I'm all done, I want the result to be a positive 10. So if I make the 20x positive, the 10x negative, then I'll end up with a positive 10x after I've added these inners and outers together. This plus sign came from the little smile, so it goes in the first parenthesis, and the minus came from the big smile. That means it goes in the last parenthesis, and there we have our final answer in completely factored form. Here's another example where we have negative exponents. Again, we can think of this as 6 minus 35 over x minus 5 over x squared, and so we can factor out that 1 over x squared from each term. Essentially what happens when you factor out is that you divide the original by this factor. And if you recall, when you divide fractions, you multiply by the reciprocal. So that will leave me with 6x squared minus 35x minus 5. So this 1 over x squared will continue to be the first factor in our factored form. And then we still need the factors of the first term, which would be 1, 6, 2, 3, xx, and the factors of the last term, 1 and 5. We have no choices here for the factors of the last term, so I'm just going to put in the 5 and the 1. I'll start with the end of the list, and I'll put in the 2 and 3, and see if I can make that work. When I smile, I get a 10x and a 3x, and there's no way to make that a 35x, so that didn't work. Try this again, 1 over x squared. Again, I have no choices for the factors of the last. I can try that 2 and 3 in a different order. Put the 3x here in the front, the 2x in the second set of parentheses, and that gives me a 2x and a 15x. Again, that will not add up to 35. So try this again, and instead of using the 2 and the 3, we'll use the 1 and the 6. We'll get a little bit smarter about how we're going to try this. This 6, we would want to get the middle term to be 35, pretty large number. So I'm going to put the 5 in the other parentheses so I can multiply those together, and then the 1 in the parenthesis with the 6. But that's only going to give me a 30x and a 1x. It's still not 35x. That also doesn't work. Believe it or not, this is our final answer. 1 over x squared times the quantity 6x squared minus 35x minus 5. Because this is factored, it's factored as much as we can factor it, because it's now all being involved in multiplication, opposed to the original problem that was a subtraction problem.